This drinking bird is a heat engine. This Stirling engine is a heat engine. The heat from my hand is enough to make it do work. This refrigerator is a heat engine. This thermoelectric generator using the Seebeck effect is a heat engine. This engine is a heat engine. This SpaceX 1D Merlin engine is a really big heat engine. Much, maybe even the majority of the world's energy is spent on heat engines. You can check out this graph from Lawrence Livermore National Laboratory. This graph shows the US energy usage in 2017. It is very interesting to see the various fossil-based and alternative energy sources. But what's also fascinating is to see where these energy sources are used. If you take a closer look, the majority of energy from natural gas, coal, and petroleum are actually spent on heat engines. And we do know that from the second law of thermodynamics, some energy must be wasted. But you will agree with me that not this amount, because it is quite huge to have 68% of wasted energy. That gives an opportunity to scientists and engineers to figure out a way to make heat engines more efficient and cleaner. Put your rod in the A base. Make sure that it doesn't reach the bottom part. Tighten it very quick. And make sure that the legs of the A base are also set up so that everything looks fixed. As you can see, everything looks great. You want to place your heat engine onto the rod. Make sure it is laying on the A base. Tighten for it to be fixed in place. Assembled as follows: a rotary motion sensor with the yellow connected into port 1 and the black into port 2, a low pressure sensor connected into channel A, a temperature sensor connected into channel B, another temperature sensor connected into channel C, and then finally an absolute pressure sensor connected into channel D. We have the 3-step pulley, the rotary motion sensor, and what you're going to want to do is to slide the 3-step pulley onto the slotted axle of the rotary motion sensor, which will allow it to stay fixed in place. Now you want to connect your rotary motion sensor by sliding it onto the rod and at about 50 to 60 centimeters from the platform of the heat engine, and make sure that it is well secured. Cut a 90 centimeter thread, triple knot one of the end on the platform of the heat engine. With the other end tightened on the mast hanger, slide it over the outer pulley while making sure that your pulley is freely spinning. And on the mast hanger, we have 220-gram mass that serves as a counterbalance. So after adjusting the thread, make sure that it is well aligned in such a way that looking on one edge, you're only able to see one thread. Feel free to adjust the rotary motion sensor in such a way that that alignment will be visible. With a pair of calipers, accurately measure the inner diameter of the aluminum can. Get some drop of water, very few of them. The drop of water will serve as an airtight seal. then you can go ahead and connect the two. Take a ruler and guesstimate the usable height of the canister, taking into account the volume occupied by the rubber stopper. Assemble as follows. And for this, you want to push, twist, and click. Again, push, twist, and click. Voila.